All right, so back. Yeah, so there's two different types of loops. There's while loops and for loops. So the main difference is that while loops will continue to run as long as a certain condition is met, and for loops will run for a predefined number of times. I have examples of both of those so you can see how they look like. So for a for and loop, basically it runs for a certain specific number of times. The syntax is when you define the for statement, you would use for, you define a variable and it equals ijk. And I is your starting value, j will be the incrementing value from the starting value, and then k is the ending value. So when you define this, when you define x equals ijk, that's basically, you're basically defining how many times you run the for and loop. So right here, I have 1, 3, 10. So that means when I start this loop, x will equal 1. And then it'll run this command right here since it's under the loop. So it'll be 1 squared minus 3. And then once this runs back, it'll go back to the beginning. And since we have 1, 3, 10, that means it'll increment by 3. So the next x value will be 4. And it'll plug in 4 for x squared minus 3. And then you get that value of x, that value of y. And then it goes back, makes it 7 and 10. Let me get my tablet out. Let's see, so it'll be like x equals 1, 4, 7, and 10. These will be like the values that you'll be testing just based off how you defined x in the for statement. And with while loops, they'll continue to run as long as a condition is met. So they will not stop after a predefined time. It basically continues as long as the condition returns a Boolean true. And usually with while loops, you use a relational operator, so like the greater than, less than, equals. And essentially, if the condition never returns a Boolean false, then the loop will go on forever. So basically we have here x is less than equals to 10, while x is less than equals to 10. So then the first value. So in the beginning, I defined x equals 1. Let me go back and annotate this. So I have x equals 1 as I defined the value of x before I run this loops. That's also something you have to do with while loops, because in this while sentence, you're not defining what x equals, you're just writing it as a condition. Whereas in the for loop, you do define the values for x. So I'll also explain that in the next slide again. But here we have x is less than equals to 10. So that means this loop will run as long as x is less than equal to 10. So our first value is 1, and then we run. And while that happens, while x is equal to 1, it'll run this code. It's y equals x squared minus 3. Then the next line of code will be x equals x plus 3. And this is basically how we'll be incrementing the x value or increasing the x value. Because if we don't increase the x value, then it will just continue to run over and over again. So because we have this x equals x plus 3, then the next x value will be 4. So first we have this, and then it'll be x equals x plus 3. And this will be x equals 4. And then since 4 is still less than equal to 10, it'll run this line of code again. This time with 4 squared minus 3 instead of 1 squared. And once you get that answer, it'll go back down here, and then you'll do x equals x plus 3, so it'll be x equals 7. It'll run the code again, and you get x equals 10. Since it's less than equals to, it'll still run. And the last time when you have x equals 13, since 13 is greater than 10, it'll stop running this code, and it'll basically end because the condition is false. As we said, it's important that when you define these loops that you're able to make the condition false at a certain point. Otherwise, the loop will just keep running over and over. So as I mentioned, basically the main differences is with for loops, you usually know how many times you're going to be running the code. And while loops you're basically running it as long as the condition is true. And the while loops can be useful for calculating error or solving equations with an iterative method. While loops are mostly useful if you don't know how many times you're going to be running a code. It's pretty easy to switch between while loops and for loops. So actually, the two examples that I described are basically the same equation, but they're just written differently using for loops and while loops. If you compare both of these, you'll see that they're the same. It's just different code because the for and while loops you have to define the variables differently. And so which of these seem more efficient for this example? Between the for loop example and the while loop example, which one seems better or more efficient?
The one on the left?
Yeah, the for loop is it's more efficient since you're writing less lines of code because you have the x values defined in this for statement. So you have the x equals 1, 3, 10. So this defines all your x values for you. Whereas in this while loop, you have to define x in front. And then on top of that, you also have to write another statement to increase the values of x. So there's you have to write a little bit more code when you use the while loop in this example. But in some cases, it might be better to use the while loop. It just depends on the examples that you're doing, the problems that you're trying to solve. All right, so the next major topic we'll be talking about is indexing. And indexing allows you to access specific values in a vector array just based on the position. So the syntax would be A, if the matrix or array is A, you would have A parentheses I, and I is the position of the array that you're interested in. So we have this matrix right here that's 1, 4, 6, 8, 19, 24. And right here, I'll just write the index positions over here. So this is 1, 2, 3, 4, 5, 6. If you've done other programming languages, you probably know that most indexing starts at 0, like if you use Python. But with MATLAB, everything starts with 1. So the first element is 1, and then it increases up like that. So that means, let's say we wanted to find out what the third element in this array or matrix is. So we would write this b equals a of 3. And this will basically return b equals 6 because that's the element under the third position. Yeah, as I described here, it takes the third position of array A. And it will equal 6 since it's the third element in the array. So indexing can be there. You have quite a bit of options if you want to choose the index. So as mentioned, you can index based on array position. So like this A of 4 is going to take the fourth element. You can index a range of values if you want. So you can also do A from 1 to 3. And this is basically the same thing as A of 1, A of 2, A of 3. If you were to do these individually, you'd have to write 3 lines of code, but you can combine it using this 1 to 3. You can also define your range of values using a matrix. So that's just 1, 2, 3. It'll take whatever, it'll index specifically whatever values you write inside the matrix. So let's say, as an example, we do A of 1, 4, 7. So in this case, it'll take the first element, fourth element, and seventh element in the matrix or array, and it'll give you those values. So this can be useful if you want to find specific values in an array, as opposed to just a range. You can also index based on row and column. So this is also called subscript. And that'll be important later as we talk about, converting between subscripts and index. But so basically right here we have A of 2, 3. So this is going to take the second row, third column, and whatever value is in that position, it'll give you that. So if I were to just draw the matrix really quickly, B2, B1, B2, C1, C2. Actually, I have to define. So if this is the matrix we have, so then A2 of 3, it'll go to the second row. So this is the second row. It'll take the third column. This is the third column. It'll take this value right here. So yeah, this can be more useful if you know like the row and column that you want to work with. And additionally, let me just erase some of this. So if you want to do, say, linear indexing with this, instead of using row and column, you wanted to do it based off position. So how MATLAB does with matrices, it counts by rows. So this will be, use a different color. So this will be 1, 2, 3. This will be 4, 5, 6, 7, 8, 9. So when MATLAB counts array positions for a matrix, it goes through each row and it counts the element based on that. So in this case, we have, then if we want to find this value using array position, it would be 1, 2, 3, 4, 5, 6. So it'll be A of 6. So basically what that means is A of 2, 3 also equals A of 6. These both give you the same value, it's just a different way of writing it. And depending on how you're defining the problem or solving it, it might be easier to use one version as opposed to the other version. So in addition to using the column rows, you can also just indicate all elements. Actually, I should just leave this matrix up here. Okay, so we have, so you could use a colon and that will indicate all elements. So what that means is, so we have a parentheses colon, and this just means it'll take all the elements in A. So it's the same as just writing A. Depending on if you're working with certain operators, you may have to use this A colon because it specifically requires you to define what elements you need to use in the matrix. So you can also, so because you have like this format, you can also do A colon 2. So what colon does, it takes all the elements in the rows, and this is the second column. So that means it will take the second column, it'll take all the elements in the rows. That means it'll take A2, B2, C2. Because you're taking all the values in the second column. Essentially, that's because that's what the colon means. Let me just erase this. And then with this A4 colon, for now we'll just make this A1 colon because we don't have a fourth row. So let's just say we do A1 colon. So that means it will take the first row and all the elements in the columns. So it will do this because it's taking the first row and it's taking all the columns. It's a little bit complicated to understand, but when you do some examples, you'll understand how it works. So converting between subscripts and index. So MATLAB has commands that allows you to convert between positional indexing and matrix subscripts based indexing. And there's basically two different commands because you can convert between index to subscripts or subscripts to index. So the first command is in to sub right here. And that just takes that'll convert your index to a matrix subscript. So this is the output that you define. You have row column. And if you define the output like that, that means that when you use int to sub, the two input arguments for this is the size of the matrix and the index, the specific index. So let's say we just want to write an example. We'd say row column equals int to sub. Actually, I'm running out of space, but this is all on the same line. I just have to write this down. And you define the size of the matrix. So we could do, let's say, 3, 4 in the square brackets. So this is just saying it's a 3 by 4 matrix, as I've sort of written here. And we have the index value, so we can do any linear value from 1 to, we can do like 8, for example. And this will take the 8th linear value, and it'll give you the row and column for that. Let me see if I can just write this real quickly. 2, 8, 3. Three. So we have 3 rows, 4 columns. In this case, what we're saying is we're taking the 8th element. So this would be this element right here. And it'll give you the row and column for that. So that means the output would be 2, 4. Right, so then this is the row and this is the column. I'll use the same example and define the sub to index, which the sub to index will convert your matrix subscripts into a linear index. So let's say we know that we have row 2, column 4, but we want to find the linear index for that. So we would say int equals sub to int. And we just put the size of the matrix, 3, 4. That should be a square bracket, parentheses. Yeah, this is all on the same line again, just since I'm running out of space. And then the row and column will be, so this will be the second row. So we write 2 because it's row 2. And then the column is the last column, so we'll say column 4. Actually, no, this will be a parentheses. And when we run this, it'll look at the size of the matrix, and since we have 2, 4, it'll say row 2, column 4 is this, and your answer would be int equals 8. So this is just a nice way to convert between subscripts and index. It can be useful in solving some of the lab activities that in lab theory. And yeah, as I've mentioned, that you have the size of the matrix is size. You can define it in a matrix form, like 3, 4. Or in some cases, you can just say size of A, for example. If you have like a matrix that's defined 1, 2, 3, 4, 5, 6, and you just write this command size of A, it'll automatically take the size for you. So this can be useful if you have a large matrix and you don't necessarily know the size. So here's an example that I've written. It's basically just, it's combining all the indexing formats that I talked about. So you guys can take a few minutes and try solving each of these, or try just inputting each of these commands into MATLAB. And basically you can notice how the answers are and kind of understand how MATLAB sort of uses indexing. And this is a good way to help you understand, because just me talking won't help that much. Yeah, take a few minutes and just solve these examples. You can also do some of these. You can do these questions too if you want. All right, so hopefully that was enough time to try these examples. Let's see. So, yeah, I'll just move on. Unless, do you guys have any questions specifically on any of these examples or how they work?
Yeah, I do. What's the difference between an index and a subscript?
Okay, let me go back to the previous slide.
Do I understand the math involved? I would just like to know the fundamental difference.
Yeah, I'll explain it again. So let me just,
Thanks.
let's say we have a matrix A1, A2, A3, B1, B2, B3, C1, C2, C3. And let's just say A equals this. So if you wanted to get, let's say, this element right here, so if you were to do indexing, it would be, you'd have to count, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. And you find that this C2 is under the 8th element. So this
Yeah.
would be indexing because it's just taking the position of the array based on
Yeah.
their position, I guess. But then
Yeah.
to use subscripts, you would say this is the third row. So this is the third row in the second column. So this will give you C2 as well. So that's the main difference between indexing and using subscripts. And yeah, these commands just allow you to convert between both of them. So as long as you, let's say you know the subscript, then you can convert to the index. Or likewise, if you know the index, you can convert to subscripts. All right, I'll just move on. So you can also index strings. It works the same way as if you were to just index numbers in a matrix. So let's say you have this string right here, and you wanted to, let's say you want to figure out what certain letters were based on the position. So if you were to type in A of 1, this will give you the S because that's the first character. And let's say you type in A of 7, it will give you A because that's the seventh position. And something to note is that spaces also count as characters. So we'd have 1, 2, 3, 4, 5, 6, 7 because the space is a character as well. So if, let me get the eraser. So let's say we wanted to index the entire word sword from Sword Art Online. So we would do A of 1 colon 6, and this will take the first to sixth element. It'll take all the values in between as well because the colon indicates that you're taking all the values between 1 and 6. So this is more useful for binary, for example. I think you go over that more in lecture, like the theory behind binaries. But then let's say you have like some, let me just write some value. So let's say you have something like this. So then you can figure out whether you have a 1 or a 0 just based on the position, and that can be useful for calculating values from binary. All right, this is the last main topic we'll be talking about. This is just the max, min, and find. So max will basically have max and min. So max will find the greatest value in a vector and it'll find its value in index. So it'll do this for each column essentially. So we have this 1, 2, 3, 4, 5, 6. I'll write this matrix out. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's say we do max of A. So in this case, what it'll do is it'll take the max value for each column. So it'll say 7, 8, 9 because it's looking at each column individually. And it'll give you it'll give you the values they'll give you the max values in addition to the position of them. So your output might look something like a val equals 789, and then IDX equals 7. Well, in this case, that's because the position and values are the same. But then let me just change these values so you can see how that would change the answer. So let's say you had like 23, 15, and 19. So then these values would be 23, 15, and 19. So yeah, the value is going to give you the max values, and IDX will give you the index of those values. So it's a good way of finding the max value in addition to the position of them. All right, and now we can do the min, which is basically the same idea, except it's going to find the minimum value as opposed to maximum. I'll change some of these values too, since 1, 2, 3 is too basic. We'll do 1, 1, and 4. So with this, the values would be 1, 1, 4, because again, it's looking at each column individually. And then you could do IDX, which will give you the index. So this will be 1, 2, 3, because this is based on linear indexing. So let's just say as an example that we had, let me draw, let's see, I'll actually erase this. See, we had 1, 2, 3, and we had 1 here. And I'll just leave this as 4. So since we are looking at each column individually, that means it would be 1, 1, 4. So these values are still the same in this case. But then the index will change because this 1 is located in the middle of the matrix. So if you were to count, it would be 1, 2, 3, 4, 5. And then MATLAB will give you those specific indexes. So it'll be 1, 5, 3. So the index is just the specific position of the values that it finds when you calculate min or max. So it's not necessarily linearly ordered. It's based on, it's going through each column as from left to right. And then you have find, which it'll find array elements for a certain condition. So let's say you have this row column, or let's say you have find is a less than 5. So it's going to take all the values less than 5. It'll give you the row and column for them. Let me just erase this. So you might get something like, because you're looking for less than 5, so you have this, this, this. You have these 4 values, actually this 2. So it'll be the first 5 values. So you'll get, for your rows, you might get 1 and 2 because you're looking at the first row and the second row. And then for the column, it will be 1, 2, 3. Actually, let me run this in MATLAB, and that should give you, I'll just do this real quickly. A equals 1, 2, 4, 4, 1, 6, 23, 15, 19. I'll show you what the MATLAB screen looks like. So it'd be row column equals find a of less than 5. All right, let me just run this. So basically it shows that the rows are 1, 2, 1, 2, 1. And then the columns are 1, 1, 2, 2, 3. Let me just write this out specifically. So row equals 1, 2, 1, 2, 1. Then column equals 1. Let me draw this. 1, 1, 2, 3, 3. So in this case, it'll take row 1, column 1, row 2, column 1, row 1, column 2, row 2, column 3, and row 1, column 3. So let me go back to the slide. Oh, I erased the example. But yeah, you can just do this in MATLAB. It'll give you the indexes for the rows and columns, and when you combine the row and column, it'll give you the positions for which that statement is true. So that's the end of my slides. Are there any questions on anything I've talked about?
I do have a question. So, do you mind going back to MATLAB itself?
MATLAB, yeah.
So, why is row certain numbers 1, 1, 2, 2, 3, while 1, 1, 1, 2, 1, 2, 1, while column is 1, 1, 2, 2, 3? Why is it like that? How did we get these numbers?
Yeah, so these are essentially all the positions for which the statement is true. So when it has row equals 1, 2, 1, 2, 1, so that's just all the rows. And then this is the columns. So you have to combine these. So you have the first one will be row 1, column 1. And then the second one will be row 2, column 1. And then row 1, column 2, row 2, column 2. So it's just you have to combine the row and column.
Oh,
How MATLAB works, it just gives you the positions for which the statement is true when you use find.
yeah,
It doesn't give you the values.
yeah.
All right, since we're on MATLAB, I'll just go over some of the activities that you'll be doing. Let's see. So yeah, the first thing he talks about is loops. And he also defines a function for you, calc trajectory. So some of the questions later will be using this function. So if you don't know how functions work, it would be a good idea to review that. But the first thing he does is he sort of calculates, he uses the function for 3 different values. And then he also does the same thing. He mentions that using a loop would allow you to run this under one loop as opposed to writing 3 different statements. We actually do an example of this later in the lab activities. So yeah, these 4 end activities are similar to what I did in the slides. So like this, it's very similar to what I did. So he's asking like what command is repeated for what values will this code perform. So what values of k will the code be run with? So in this case, it'll be 1, 4, 7, 10. And he's asking what command would be repeated. So it would be this command that's written under. It would be anything that's written under the loop between for and end. Anything that's written will be repeated until the loop ends. And he has these little sliders so you can mess around with the values and see how that changes some of the results. And he wants you to modify the code to use even powers. So I sort of solved it, but it shouldn't be too hard. So activity 2, as I mentioned, is he just wants you to convert the for loop into a while loop. So you would just sort of follow the similar structure that I did in the slides. And he also asks you which type of loop is better for the examples. So we also answered that in the slides. So activity 3, what he has is he talks about how you would calculate errors in MATLAB. And sort of he tries to estimate machine precision. So that means that's basically the maximum round off error in MATLAB. So MATLAB it uses 64-bit double precision numbers. So that means that only a specific number of digits can be stored within MATLAB. And if you have, let's say for example that MATLAB can only store 64 digits in a 64 digits after a decimal place. And let's say a number has 65 digit places, then it'll round the 65th digit into 64th because MATLAB can only store 64 digits. Again, that's just an example. And what he does here, and he approximates how he basically approximates at what point does MATLAB start rounding numbers. So he has epsilon equals 1, and he writes this while command while epsilon plus 1 is greater than 1. And basically what he does here is he divides epsilon by 2. So epsilon equals epsilon divided by 2. And it goes back here, and you run epsilon plus 1 is greater than 1. And if that's true, it'll divide by 2 again. And this loop will basically continue dividing by 2 as long as epsilon plus 1 is greater than 1. And so the main thing he's trying to do right here is because you have epsilon plus 1 is greater than 1. Well, basically we have epsilon divided by 2. So this is just going to epsilon divided by 2 is going to keep being smaller and smaller. And at some point, the value is going to be so small that it equals 0. So let's just say we have like this value, for example. And let's say this value is too small for MATLAB to describe. It's just going to round this down to 0. So then when you run this again, it'll be 0 plus 1 is greater than 1. So this will be 1 equals 1. And since this statement would be false, it'll end the loop. So one thing he does, the main thing he wants to do, he wants you to calculate the number of iterations it takes to approximate machine precision. Then that would basically be how many times does this loop run until it goes to the end command. So basically this would be like using a counter. Whenever you write loops, sometimes you might decide to write a counter. So usually you would just use n equals 0. So this is the starting value. And then when you write your loop, what you'll do is you'll write in this n equals n plus 1. And what that does is it basically runs the loop. And at the end of the loop, it adds 1 to n. So basically the first time you run this loop, well, it starts at 0, and then when it runs this command, it'll go to n equals n plus 1. So then n will equal 1, and then it'll run this loop again, and when it does, n will equal 2, and then whenever this keeps running, the value of n will be increasing by 1. So this would be a way to essentially count how many times the loop is running. And at the end, I just write display n, so then you can see how many times the code is run, or the loop is run. And so right here we have 53 times. So that's the number of times this loop is being run. So if you were to do this by hand, you'd have to do it 53 times, which wouldn't be that fun. But in MATLAB, you would just have to run the script. So it's basically a similar concept over here. So he has test equals 1. So while test is greater than 0, what he does is he divides by 2, and then he compares it to test is greater than 0. And as long as the value is greater than 0, it'll continue to run this loop. So the same idea is that he's basically trying to determine at what point does MATLAB just round the value to 0. So if you have like a really small value, at some point MATLAB will just round this to 0 because the value is so small it can't store it in its index, or it can't store it in its digits. So he's trying to determine at what point does that happen, and then it just ends the loop. So we could also, if you want to find out how many times this loop runs, you could do something similar. We do n equals 1, n equals 0, and then at the end we do n equals n plus 1. So this n equals n plus 1 will always be the last line in the loop. It'll be right before the end statement because you want to check to make sure that the entire code is being run. So then you would do let's just run this. Actually, I'll do the same thing I did before. Ooh, my goodness, that's a lot of n values, but display n. Let me just run this again. So 1075 is the answer here. So basically that means this code is being run 1075 times. And this line of code is being run 53 times. So the main question he wants you to answer is what value does it return for epsilon? And why is it different from the code above? So basically this code. And you have to consider the difference between machine position and the smallest representable number, which I think he went over in lecture. I'm not sure, but in any case, you can just redo the lab handout, and that should help you with that. So he goes over indexing as well. And let's see. So yeah, he gives you an example, but he defines this vector, and he wants you to find the fifth element in this vector. So it would just be VC1 parentheses 5. So this will give you the fifth element, which is 18. So in the beginning, we talked about how you would use, if you were to use functions, and let's say you want to calculate a function for 3 different values, you would have to run the function 3 different times. And that it might be okay if you were to do it 3 times, but if you were to do it like 10 or 20 times, it might be better to just use a loop. And so he gives you a template here, which is basically how he wants you to write the code. And there are certain things you also have to define before, but this is the main format. So the first thing you have to do is you define data as a matrix of values between 30, 45, and 60. And he has data defined in the beginning of activity 4. So this is basically these are the values that you're going to be plugging into your function. So the main thing is, since calculate trajectory it'll calculate the trajectory for any specific angle. So you want to find out the trajectory for 30 degrees, 45, and 60. So that's why we're going to be running this code, running the function 3 different times, because it's only one input argument. So what we would do is we define data, and then again we use this for k equals 1 to 3. And when you write the for statement, it's going to define how many times the code is being run. So in this case, we're saying 1 to 3. And since we are doing since it's 1 to 3, it also aligns with the linear index positions for the data. So if I were to just write this out, let's see, 30, 45, and 60. So yeah, this is also 1, 2, and 3, which also matches up with how we're defining k. So then this x colon k and y colon k is basically, it's a way to define your output matrix. So again, when you do colon comma k, let me just write this. So it's going to write all the elements in the rows, and it's going to do that for the first column. So what it's doing is it's going to take all the answers and it's going to store it in the first column of k. So this is useful if you want, since you want to store all the values that you obtain. So you do calculate trajectory data of k. So this is basically like data of 1. It's going to take the first element, and then it'll go through a second time. So this k will be replaced with 2. And when you do this, it's going to store all the answers in the first column. And then when you run this again, this k will be 2, so it'll store all the answers in the second column. And then the third time, it'll store all the answers in the third column. And basically, the trajectory data k will be storing. It'll take the elements from data based on the position. So data of k it'll be 1, 2, and 3. Let me erase this. So yeah, as you see, like when you run this code, the first time it's 100 times 1, because just how the function is defined, it'll give you 100 values when you calculate the trajectory. And the second time, you see that these are the answers from the first time we run the loop, but then the second time, it's going to have the answers here. So these are the answers for 30 degrees. This is the answer for 45 degrees. And then this last column is the answer for 60 degrees. So that's pretty interesting. This is basically how you'd be able to store your answers each time you run a loop. And once you're satisfied with the loop, then you can uncomment this code and it'll basically graph the answers for you. So what else? So yeah, this is just the row and columns that we talked about. He does index to sub. So he tells you to look at sub to end, and then basically find the linear index in the 5, 8 position for a 10, 13 matrix. So you would just follow the format for sub to end, and you would just make sure that your input arguments are the same as the question that it's asking. Do we talk about the colon operator? Let me just look over this example. So magic 4 just creates, what does magic do? Well, let me just search that up quickly. All right, so magic will just create a random matrix. And what that means is that the sum of each row and column will be the same. So if you take the sum in row 1, it'll be 15. And when you take the sum from column 1, it'll be 15. So so that's not really important, but that's just explaining how magic works. So yeah, so when you take, let's say, m colon, it's going to take all the values in the matrix. It's going to start with the column, so it'll be 834159672. So it's just looking at each column and taking all the values, because that's what colon does. So then we have magic 4, which is a 4 by 4 matrix. Let's say we do 2 colon, so it's going to look at the second row, and it's going to take all the elements in the columns. Yeah, so it looks at the second row, takes all the elements in the columns. So that'll be 5, 11, 10, 8. And let's say we do colon 3. And this time, it's going to look at the third column, and it's going to take all the elements in the rows. So a good way to sort of think about this is basically, let's say you want all the elements in the fourth row. So whenever you define the row, so whatever you want to find out, you would write the number, and then the colon will just take all the values from that. Originally 2. So let's say you want to find like the third column, let's say the first column. So you would just do colon and 1. And he has a few more examples too. He goes through some different ways of indexing. See, he goes over how you would index strings. And yeah, over here he talks about binary notation and the difference, like the bit 1, bit 3 to bit 8, and how that represents different elements of the number. So like he has a number here, and he defines like the different parts of different parts of binary based on the position of the string. Let's see, and yeah, we go over max, min, and find. It's just similar to the examples we did. So right here, he wants you to find the maximum for each row of matrix M. So whenever you run max, so let's just say x equals the x value. Let me just check on MATLAB. So we could do M I, we do value index IDX equals max of M. Let's say we run this. So in this, it gives you 9, 7, 10. So 9, 7, 10, and the index values are 2, 1, and 3. So if you're wondering why it's 2, 1, and 3, so it's looking at each column individually and taking the index position of that. So in this case, when it's saying 2, it's 1, 2, because it's treating each column as its own matrix. So when you run max of m, it's similar to just saying max of 891, max of 762, and max of 3510. So when you run these, it's looking at each column individually. Even if you just say max of m as the whole matrix, it's going to take the max for each column in that matrix. So that's why you have 2, 1, and 3, because in this case, when you look at this, it's the second value. When you look at this example, it's the first. And then when you look at this, it's the third. So the IDX values might be a little different when you IDX values, it's a little different when you use the max and min values. That's just because it's looking at the columns individually. Let me scroll through. Where was it? Yeah, to find the maximum of each row. Actually, I can just show you the MATLAB documentation. So let's say you wanted to find out more about max. So you could just type in like MATLAB max. You click on mathworks.com. It'll it'll bring you to this page. It'll show you like a variety of commands that you can use. So obviously in the labs that we go through, when I write the slides, it's just the basic examples because we have a lot of topics to cover. But if you want to learn more in depth, you could just go on MathWorks, or you could just search for specific examples on MATLAB and you'll be able to find them. So the example that he asks you to do, he wants you to find the maximum of each row of matrix M. So you can look through these descriptions and see if you might be able to find an answer to the problem. So right here, it tells you that like the maximum element along dimension M. So here it says like if the matrix is defined as max A square brackets 2. So all of this is in parentheses with commas. It gives you a column vector containing the max value of each row. So this is basically how you would answer the question that he's asking in the lab, right? Because he wants you to find the maximum of each row of matrix M. And just from looking at MathWorks, you'd be able to find that this right here is how you would define the max command to find the maximum value in each row. So it can be useful sometimes to just search for answers online, and if you basically do a lot of reading, you might be able to find the answers. So I have it here defined as well. So when you run this, it gives you 8, 9, 10. And that's because this time it's looking at each row. So it's giving you the max of 8, 9, and 10 because those are the max values in the rows. Whereas when you just write max M, it's going to look at the columns. So when you write just max M, it's 9, 7, 10 because those are the max values in the columns. And then when you run this, it's 8, 9, 10. And we can actually do the same thing, val idx. If you were to run this, it'll be 8, 9, 10, 1, 1, 3. If you go back, because it's 1, 1, 3. So when you look at these indexes, it's important to consider how the code is being run, because the index values will mean something different depending on how it's being run, whether it's looking at rows or whether it's looking at columns. let's see, and then he has you do find. I also just found this online, but it's a little bit complicated, but it's basically you would have to use the max command, and then you would find the matrix equals the maximum number, and you convert it to int to using int to sub. And then you could also, because he wants you to find, let's say, the overall maximum, the largest entry in M, right? So let's just go back. So by default, when you run maximum, it's going to look at the columns, but let's just say you want to find the maximum value, so the one greatest value in the matrix. So that would be 10. So he wants you to write a command that finds 10 as the answer. Let's see. It's defined here as well. So this max. So when you write max a square brackets all, it's going to find the maximum over all elements of A. And this will work for MATLAB greater than 2018. If you have a higher version than 2018, it should work. Actually, it also mentions about linear. So when you, let's say you run this max all command, but then you also want to find the indexes, you'd have to type in this linear. So basically what I did was I did max M square brackets all linear. What this will do, this is going to find the greatest value in the matrix and then its index as well. So some of these you just have to find online on MathWorks because the questions are a little bit complicated. And then at the end, he has the calculate trajectory. And yeah, he just defines the function so you can see how it looks. So that's it for me explaining the labs. So hopefully that was clear. I gave you some hints on how to solve some of these activities. What happens if two men are in the same column? Actually, let me try that. I think it might give you both values, but I'm not sure. Let's see. I'll share my screen again. Oh, is it sharing the screen? Let me. Okay, share screen and let me just clear this first. Let's just make this 1 so that way when you look at the columns, it'll be 1, 1, and 23. So we'll have two minimum values in this case for the first column. We'll do row idx equals minimum of A. Run this. So it gives you 1, 1, 4. And it gives you 1, 2, 1. So basically it's gonna take the first minimum value that it finds based on the matrix that it has. So even though both of these are 1, and these, so 1 and 1 are both the minimum values. So in this case, 1, the first and second position of this column are the smallest values. But when you look at MATLAB, it's taking the first value from the column. So it's looking at this value because that's the first minimum value of this column. So hopefully that answers your question. If you have two minimum values in a column, actually let me stop share.